Example 3. Use Euler's method with step size 0.1 to construct a table of approximate values for the solution of the initial value problem. Y prime equals x plus y, and y of 0 equals 1. Solution, we are given that h equals 0.1, x sub naught equals 0, y sub naught equals 1, and big F of x and y equals x plus y. So we have y sub 1 equals y sub naught plus h big F of x sub naught and y sub naught equals 1 plus 0.1 open 0 plus 1 close equals 1.1. Y sub 2 equals y sub 1 plus h big F of x sub 1 and x sub 2 equals 1.1 plus 0.1 open 0.1 plus 1.1 close equals 1.22. Y sub 3 equals y sub 2 plus h big F of x sub 2 and y sub 2 equals 1.22 plus 0.1 open 0.2 plus 1.22 close equals 1.362. This means that if y of x is the exact solution, then y of 0.3 is approximately 1.362. See the sidebar. Computer software packages that produce numerical approximations to solutions of differential equations use methods that are refinements of Euler's method. Although Euler's method is simple and not as accurate, it is the basic idea on which the more accurate methods are based. Back to the text. Proceeding with similar calculations, we get the values in the table. There are columns for n, x sub n, and y sub n from 1 to 10. For a more accurate table of values in example 3, we could decrease the step size, but for a large number of small steps, the amount of computation is considerable, and so we need to program a calculator or computer to carry out these calculations. The following table shows the results of applying Euler's method with decreasing step size to the initial value problem of example 3. Sidebar, module 9.2b shows how Euler's method works numerically and visually for a variety of differential equations and step sizes. Back to the text. Notice that Euler's estimates in the table below seem to be approaching limits, namely the true values of y of 0.5 and y of 1. Figure 15 shows graphs of the Euler approximations with step sizes 0.5, 0.25, 0.1, 0.05, 0.02, 0.01, and 0.005. They are approaching the exact solution curve as the step size h approaches 0. See sidebar of the graph of a table, pardon me. You have step size and then Euler's estimate of y of 0.5 and Euler's estimate of y of 1. See figure 15, Euler's approximation approaching the exact solution. Example 4. In example 2, we discussed a simple electric circuit with resistance 12 ohms, inductance for big H, and a battery with voltage 60 big V. If the switch is closed when t equals 0, we modeled the current big I at time t by the initial value problem. The derivative of big I with respect to t equals 15 minus 3 big I, where big I of 0 equals 0. Estimate the current in the circuit's half a second after the switch is closed. Solution: the Euler's method with big F of t and big I equals 15 minus 3 big I, t sub naught equals 0, big I sub naught equals 0, and step h and step size h equals 0.1 second. Big I sub 1 equals 0 plus 0.1, open 15 minus 3 times 0, close equals 1.5. Big I sub 2 equals 1.5 plus 0.1, open 15 minus 3 times 1.5, close equals 2.55. Big I sub 3 equals 2.55 plus 0.1, open 15 minus 3 times 2.55, close equals 3.285. Big I sub 4 equals 3.285 plus 0.1, open 15 minus 3 times 3.285, close equals 3.7995. Big I sub 5 equals 3.7995 plus 0.1, open 15 minus 3 times 3.7995, close equals 4.15965. So the current after 0.5 seconds is big I open 0.5 close is approximately equal to 4.16 amperes, big A. Sidebar: Euler or Euler, Leonard Euler or Euler, from 1707 to 1783, was the leading mathematician of the mid-18th century and the most prolific mathematician of all time. He was born in Switzerland but spent most of his career at the academies of science supported by Catherine the Great in St. Petersburg and Frederick the Great in Berlin. The collected works of Euler, pronounced Euler, filled about 100 volumes. As the French physicist Arago said, Euler calculated without apparent effort, as men breathe or eagles sustain themselves in the air. Euler's calculations and writings were not diminished by raising 13 children or being totally blind for the last 17 years of his life. In fact, when blind, he dictated his discoveries to his helpers from his prodigious memory and imagination. His treatises on calculus and most other mathematical subjects became the standard for mathematics instruction, and the equation e to the power I times pi plus 1 equals 0 that he discovered brings together the five most famous numbers in all of mathematics.